Prof, can we start the session?
Oh, no problem.
Okay, I'll be the master of the ceremony today. So, very good mornings to everyone, and welcome to the webinars, competing on analytics in logistic management. This webinar is collaborations between UTAR and Faculty Department of Logistics and Marine Studies, Faculty of Business, Hong Kong Polytechnic University. And our speaker today is Professor Zhou Xu. Okay, before we start, I would like to give a brief introduction about Prof Zhu. Okay, Prof Zhu is currently a professor in the Department of Logistics and Maritime Studies at the Faculty of Business, Hong Kong Polytechnic University, or HK PolyU. Prof obtained his PhD degree in the year 2007 from the Industrial Engineering and Data Analytics Department of the Hong Kong University of Science and Technology, HKUST. He got his master degree in the year 2003 in the areas of computer science from the Computer Science Department of the National University of Singapore. So it's not very far from us, Prof. National University of Singapore. And Prof got his bachelor degree in year 2002 from the Computer Science Department of Tsinghua University. Okay, ladies and gentlemen, for your information, the research area of Prof. Xu is focused on the application of operation research and computer science techniques to the problems in logistics, transportation, shipping, and supply chain. So these are the areas focused by Prof. Number 1, logistics. Number 2, transportation, shipping. Number 3, and number 4 is supply chain. And Prof has published more than 40 articles in mainly premier journals, including Management Science, Operation Research, Informs Journal on Computing, Production and Operation Management, Transportation Science, Transportation Research Part B, Naval Research Logistics, Interfaces, Communication of the ACM in each. Wow, Prof, this is a very good journal, Prof. Congratulations.
Thank you.
Okay. His research work has been translated into a strategic procurement and bid optimization system, which will help a global electronic company to source transportation services thousands of lanes in the world. So I believe, Prof, with your research, is a combination of supply chain, transportations, and also the logistics activity. It's a very, very wide this area, Prof. Okay. This session will be a 1-hour session. So without further ado, I would like to call Prof. Zhu. The stage is yours, Prof.
Okay. Thank you for your nice introduction. So let me first share my slides here. Okay, so can you all see my slides? Can you see the slides?
Yes, Prof. We can see your slide.
Okay, thank you. It's my great pleasure to have this opportunity to virtually visit UTAR again. Okay, so give a talk to share my experiences, including my research about logistics and its management. Right. So today my topic, the title is Competing Analytics in Logistics Management. Okay, so here's this is my brief introduction. I have been in Polytechnic University since 2007, so it's almost 15 years. And my teaching mainly focus on information technology with its application in supply chain management and logistics. And also I'm doing research on logistics management as well, but mainly focus on how to use business analytics to solve logistics optimization problems with focusing on application in transportation, shipping, and supply chain management. Okay, So today my topic is competing on analytics in logistics management, right? So this is a formal topic, but most likely informal one is competing on cheating, right? So when I thought about this topic, competing on analytics in logistics management, I was thought about a news like I heard quite a few years ago. So nowadays we are very keen in watching football games, right? So FIFA 2023 or 2022. So, but quite about 15 years ago, so there's also a FIFA game in 2006, and in the semifinal there's the Argentina versus Germany. Okay, it's a very famous game, but they go through into the penalty section in the very last. So Argentina actually lost the game, but the goalkeeper Lehmann of Germany saved the game. So he saved quite a number of. He actually every time the Argentina player make the goal, he actually picked the correct way in the penalty section. Right. So every time he got a correct way, and he saved quite a number of goals, and the German go through the semifinal. So, but what is the secret for Germany to win the game through these panel sessions? Right. So in fact, is Lehmann a great goalkeeper? So he's a great goalkeeper, right? So in this game, he gets 4 direction out of 4, correct direction out of 4 in the penalty, okay, and saved 2 goals and helped Germany to win the game, right? But look at this picture. So people actually the journalists actually have this shot and find before the penalty, the goalkeeper is reading some notes, right? And then they find out there's a notes that he was reading. The notes are showing some information about a guess what for each player in Argentina which direction, right? The player will shoot. Okay, so some may shoot left high, some may shoot left or long run or short run. What will be high possibility, right? So he actually has cheating notes, and notes that help him to make the right guess of the opponents, the penalty shoot. Okay, and so this is actually related to managers in logistic management when they make decisions, because he's kind of as the manager of the goal as a goalkeeper. He's the kind of manager of the gate. Right? He needs to solve some problem. Right? The problem is you have to make a decision. And it's a very complicated decision, although the form is simple, but it's a lot of possibility, right? So you need to make a decision which direction you're going to the player will go for, right? And of course, what is the objective? The objective is also an optimization problem, right? You need to optimize maximize the possibility of the success, right? Which direction have high possibility for each different player of Argentina? Which direction will be the higher possibility for his success, right? But how he got these notes? Notes actually is provided by their assistant, coach assistant. So they have to do a lot of analysis of historical information about different players in Argentina. They may watch video or games on site for many times, and they got some information, and then come out with a conclusion that for each player, which direction will have a higher possibility, right? So they're trying to use information in the historical data to help goalkeeper to make right direction. And the way is they're trying to maximize the possibility of the success in its decision, right? So this is how they make decision, and they actually win because they have this cheating sheet, right? Lemon have this cheating sheet. It's quite well known as Lemon's cheat sheet, and it is about that topic we're going to talk about, how to analyze historical data, how to analyze the information so that manager can make a right decision in their logistics problems, right? So today, this is about like 15 years ago, right? So today, if you go look for these soccer video analysis software, there are actually a number of them. And I actually go to this isportanalysis.com. You can find there's a software talking about how they use artificial intelligence to help soccer manager or coach to analyze the performance of their players so that they can make a right coaching plan to help their players to improve their performance, All right, you can upload those soccer video and select those some of the tools and to tag these actions in the event, and the system will help to analyze to show the performance of each player of your team, maybe each player of your opponent's team, so that you can know the opponents better and know your team better, and to have a better strategy in the game, and also have better strategy in your in the training session, right? So this is all a more a kind of tools that used in sports. Okay, so they're also similar, but as you see that what they use is to use historical data and to do the analysis, and so that they help the soccer players or coach to make correct decisions, and they to bring some benefit to the sports team, right? So this is how they trying to make right decision using technology and using analytics. Okay, so this is actually related to what we are going to talk about today. So we are going to talk about how competing. So in the games, soccer teams are competing on how to use data, how they competing on the cheating sheet they have, right? But in the real business, right? Business, how the business can competing, so they probably have to also have a similar cheating sheet, help them make better decisions, to make to handle those complicated business scenarios, right? So here, the cheating may not refer to the behavior in dishonest way. It may, I believe, it referred to behavior in a smart way, so that you can get what you want. For business, for sports team, you can win the game, you can get victory. But for companies, you probably have to have a smart way to get your profit. Okay, get profit and get revenue to the firm, right? So yeah, in real business world, the situation is probably as complicated as in the soccer game, or even more complicated, right? So you have to deal with the changing environment of your business. You have to deal with a lot of uncertainties, right? The cost, particularly in the environment today, right? So there are a lot of uncertainties. People talking about resilience of supply chain. There are a lot of disruption, right? So how company can compile those. But on the other hand, you can with the support of information technology, company also have a lot of data, a lot of historical information of your business, about your customers, about your products, of your suppliers. But how decision maker in the business world can have a smart way to compile these information in a proper way, in an efficient way, so that they can make better decisions. How they come out with their cheat sheet, right? Their cheat sheet. So this is a challenge for managers in the business world today. Okay, so yeah, how to have a cheat sheet for business decision makers, right? So this is what we are going to talk about today. So this is also my research interest, where I'm talking. What I'm really doing my research is to investigate different complicated problem in logistics management, and think about solutions for company decision maker to help them to support their decision making, right? It's kind of to prepare a cheating sheet for them, or tools for them. Okay, so let me first share with you a case that I have been through to help a global electronic company, a global shipper, to help them to make a right decision in the transportation service procurement, right? As mentioned in the very beginning introduction, I actually helped to a company to manage their thousands of lanes in the transportation service procurement, right? So in the transportation service procurement, it's also very complicated. So there are different players in the transportation service market. You can think about. I think many of you are familiar with logistics industry. Okay, similar in the logistics industry, particularly in transportation service industry, you have shippers who have these cargoes, right? So there are shippers who have these cargoes. They can be manufacturers like Philips Electronics, like a GE. You can also have retailers, big retailers like Walmart, like Metro, right? So you're probably familiar with, and they have a lot of cargoes to ship, okay, around the world. So even today, in the pandemic, although the passenger transportation kind of been blocked for some time, but cargo industry, cargo transportation is very hot along this pandemic period. Okay, there are a lot of volumes of cargo, actually growth of the cargoes in this pandemic period, and all the shipping rates also higher. But they also have a lot of uncertainty in this thing during the pandemic for the shipping industry, right? So in the shipping industry, we have shippers. Shippers have those cargoes. The cargoes based on what they have for their customers. And on the other hand, we also have carriers. Carriers are service providers. So they have vessels, they have transportation equipment like containers, and they have vehicles in different modes, right? They can have aircrafts, they have trucks, they also have container ships, right? So they are service providers, carriers. And also we have facility operators, particularly ports or hubs, right? We have airport operators, cargo operators, port operators, ocean port operators, and so on, right? So this is a market with different three kinds of different players. And for the shippers, they have to make very complicated decisions because for global shippers, they have cargoes all over the world to ship from one place of the world to the other place of the world. So it's very common a cargo may be shipped from factories in China or in India and move to European countries or American countries, go through ports probably in South Asia like Malaysia or Singapore, or go to East Asia like Japan, Korea, and go to their destination, right? So it's a very complicated route, and you can see the routes are also, there are many kinds of routes, right? So therefore, including shippers, carriers, and ports, they have to make right decisions so that to make transport service market be efficient, right? So let's first focus on the shippers. So for shippers, how they are going to select carriers. So they have different carriers for different shipping, right? OCL, K-Line, Maersk, they're all for marine transportation or ocean transportation, right? So they have to select transport lanes, and they have to allocate their cargoes in different times to these carriers. So there are a lot of possible configurations. And their cargoes actually shipped for different departments of the company, right? For manufacturers, you can have departments for different products. They can be medical products, lighting products, or custom electronic products and appliance, digital appliance product, and so on, right? So but how they're going to make decisions, how they can come out with a cheating sheet to help them to make a smart decisions to minimize their total cost, right? So as we mentioned in transportation service procurement, there are different players like shippers, carriers, right? So FedEx, DHL, also carriers, therefore courier, express, go through multimodal transportation, including aircraft or also ground transportation. And we also have port operators like Huaichong ports in Hong Kong, Yantian, Shekou in China, and Port Klang in Malaysia, right? So these are also very well-known ports in this region. And so for the transport service that go through shippers, right? Shippers factories or warehouses, and they maybe go through ground transportation by trucks, and then go to the ports, ocean ports, and then you can take vessels, container vessels, and ship to their destination port. And there you may also go through a truck service and go to your customer's door, right? So that can be a door-to-door service or port-to-port service, right? So as you can see, transport service market, you have multiple players, and their lanes are quite a lot, and they have different choices for shippers. You have different choices for carriers, or even for their different modes of transportation, including ground modes, also ocean transportation, and aircraft transportation, and also sometimes in China or in some occasions you also have cargo transportation go through railways, right? So these are transportation service that need to be chosen by shippers. And for shippers, they are in this market. If we look at shippers, they are the buyer, right? They buy the service, and the carriers are the seller. For this transporting service market, what is the product? The product is a shipping service. It's not a physical product. It's like a virtual service. So it's a virtual product. It's called shipping service. And shipping service has a different characteristics. You have to specify its lane, right, from one origin to the destination. For example, from Shenzhen and to Rotterdam, right? So that can be a lane. And they also have a different mode, right? You can have a mode by air, by ground, or by sea. So they have different mode, and their shipping time can also be different. You can have a courier service. The shipping time is very short. You can also have services with normal service, or normal the shipping time can be longer, right? And because of the time or mode different, the rate will also be different, right? The shipping rate will also be different. And shipping service also have their volume or their volume capacity. And the rates may also depend on the volume that purchased used, or the capacity used by the shippers. It's very common that carriers will offer a volume based discount. So basically saying, if for the whole year, if you buy more than 100 containers, probably you can get maybe 20% discount, right? So that's a volume-based discount. So the product is very complicated. It's not like a desktop or computer, a laptop. So for shipping service, they have multiple dimensions to characterize its features, okay? And all will affect their final shipping rate. And so this is a different mode of the shipping, and this is a different lens. So here we can see the different lens. And so for the shipper, every year, large shippers like what have been working with at Philips, they have been spent hundreds of millions of dollars in the purchase of shipping transport service. So they have thousands of lanes by sea, by air, by courier express. It's very big, important. It's very important the business activities in the firm, right? So if you can save 1% of the cost for the firm, that's a lot. That means a lot for the that means $1 million for the company. Okay, so therefore they do this transporting service in a consolidated way, right? So for the company that I'm working with, they have a general purchasing, forward, and distribution department in Hong Kong, right? So they will in charge the global transportation service procurement, right? So every year they will kind of have annual exercises in the beginning of the year to ask the carriers to quote the lanes they need for their transportation, and impose all kind of constraints for their based on their business practice, and to choose the best combination of the carriers and allocate the most efficient allocation of the cargoes to these carriers to help them to save the money. Okay, so as you can see, they are different for different carriers. They have different lanes, right? So the problem actually is very complicated. Right? So here's a very typical transportation service procurement process. So for the firm, usually they will start with the forecasting of the demand. So you have to know what the cargo demand, so that you can determine how many cargoes you can allocate or commit to your carriers. Okay, and then they will have an auction. So it's a kind of reverse auction. In the traditional auction, its auction is for selling items. But in the procurement exercise, the reverse auction is to buying the product. You have something to buy. You ask the providers to bid for the quantity you buy. Okay, and you can choose the minimal among those bidders. Okay, but in the reverse auction for the transport service procurement, it's quite complicated. It's not as simple as the traditional item item bidding, right? Because their product is complicated. For the item, you can, if you have painting, right? It's a very it's kind of very, the features are very simple. But for the product, for the transport services, usually the company will buy a number of services, right? It's a group of services. It's a combination of the products, right? And they will also use this combination as a bargaining power, right? To ask for quotation. And they will also, all the kind of business constraints also make the decision complicated. So there will be a post-bid allocation for the analysis. After analyze of the bids submitted by the carriers, the company will do some analysis, right? So make a decision, okay, on the allocation of the cargo on the selection of the carriers first, and then allocation of the carriers, allocation of the cargoes to the carriers, okay? And then they will make a contract and do the execution, okay? The performance will be evaluated, and these carriers' performance will later on as an input for their later future analysis for the allocation and the contracting. Okay, so here are some example of the document data that company need to make decision in this procurement process, right? So here, so usually in the request for quotation process. Okay, so they need to ask the carriers, okay, to submit their rate for different lands, right? So here are the many different thousands of lands there, and it specify what are these origin and destination, and it specify what are the quantity that for the whole year you want the carrier to ship for you, and then the carrier will add their service, their quotation, including like maybe transportation time, so service time, and all the kinds of cost items, right, in the transportation. And then there are thousands of rows in this Excel sheet, and they will be submitted by each bidder. So usually there will be like 7 or 8 bidders of the world, and major carriers, and including some local carriers. Sometimes there can be up to 20 carriers for one each exercises, right? So as you can see, there are thousands of rows in this exercises. They're quite a lot, and there are many information exchange with the carriers. Carriers have to provide shippers have to provide a quantity of their demand, the quantity of the cargoes to ship all over the year. Okay, and also they have to provide their constraints, right? So what kind of constraints along the time of the year, and they also need to receive the information from carriers on the cost factors, on their shipping time, and so on. They also have to share what kind of criteria they want to in their selection of the carriers, right? So also this decision is very important because it affects the value of decision is millions of dollars, right? So that's very important. So the decision is very complicated. The data information is very complicated, and decision is very important. But on the other hand, the decision is also very complicated. Think about how many you have. Like if you have 20 carriers, you have thousands of lands. The combination of carriers, allocation of cargoes can grow exponentially, right? So that's you have millions of possibility for the decision. So that sometimes if you do it manually or even just using Excel to do the analysis, that can also make you crazy. Okay, so that so what the company do in the legacy solution is they do through communication with the emails, okay, with the carriers, and when they make decisions mainly based on experience, they do very few analyses because they're too complicated, right? So they just have some rule of thumb, and for example, they come up first, look at each land, what will be the minimal value, which carrier will who actually quotes the minimal rate, right? So they may probably select the carriers with the maximum number of lands that whose rate is minimal. Okay, but that will come out with some problem because these carriers probably will also bid some of the highest rate for the lands, and these carriers sometimes may not have enough capacity. Okay, and these carriers may not, if you take into account of the volume discount, these carrier may not be the quote for the lowest rate. So that can be another issue. So that's why they find potential to use the analysis of these data to make a better decision and to help them save the time and save the cost, right? So essentially, we help them to build up an information system to streamline the whole procurement process. And in this process, we have these request for quotation and also call for bids, request for quotation, and help them to manage these data using template and using data file, and then to help them to do the analysis, right? So we can help the company to do a forecast, can help the company to upgrade bidding data and to generate a benchmark data to do the analysis of the data, and also to run optimization to optimize the decision for the selection of carriers as well as the selection allocation of the cargoes, right? So this is what they can upload. They just download the information from the this information hub, right? So they don't have to do the email through the email for information exchange. Now they can use the information system to do the information exchange, and on the same time they can fill the information and upload the data to the system. System can help them to verify the data to see whether there's any typos and so on to save the money for the carriers. And then the system can create scenario for analysis, right? For each different scenario, they can set up do the configuration, and the configuration including different constraints and for their analysis, and then run the optimization engine to explore different possible decisions and choose the best and for the company. Right? Then they will generate the allocation of the cargoes for different carriers, and for each carrier, for each lane, which carriers you're going to select, and how many cargo you're going to allocate it. So these are the cargo allocation, and how many cargo you're going to allocate it, and also what will be the cost. Right? So they will do the analysis. Okay, and so actually the company use this system. Okay, use the system, and they have use the system to facilitate the data interchange with the carriers, and also at the same time they also use the system to analyze the information and use the system to support the decision making, use the optimization for the allocation of the lanes, right? So they reduced a lot of time for the analysis. So the whole analysis, the time for the analysis actually reduced from weeks to just a few minutes. So which means that they can do more scenario analysis, right? So if your analysis is for weeks, probably can only do one scenario, right? Because the demand can be very different in different situations. You can come out with analysis for different situation of your demand uncertainty. And but in old days, if you do analysis for one shot of analysis for several weeks, then probably they cannot do much scenarios. But nowadays they can use a system to reduce the time for just a few minutes. Actually, they have to do quite a number of analyses for different scenarios, and to help them to make better decisions. And analytical results will be more accurate and more comprehensive, and also the cost saving is significant. Okay, so the key part of this system is the optimization engine. So the optimization, what the optimization engine do is they will receive the information from the carriers and from the shippers, right? So these information including the shippers' demands, the carriers' the bidding rates, and the capacity of the carriers' services, and their different discount terms, and also shippers' minimal quantity commitment to the customer, right? So we have built several models. This is one of the models which take into account demand, bidding rate, minimal quantity commitment, and capacity. For this such a scenario, we built a mathematical model for optimization. The objective is to minimize the total cost. That includes the total transportation cost and the total cost of the selection cost of the carriers. Because different carriers, your interaction costs with the carriers will be different. Right? We take into account the total cost of transporting costs and operational costs for interaction with the carriers. And then the variable X decision is made for your allocation. You allocate the lane in J, okay, to the carrier of I, right? So you have to decide which carrier you have to, how many cargoes you have to allocate. So the total allocation, you have to reduce the capacity for, you cannot exceed the capacity of a particular carrier. And you also have to make a minimal commitment to the carrier. Your total allocation to the carrier I should not exceed its capacity. If you select carrier I, your total allocation of the cargo to the carrier have to exceed its your minimal quantity commitment. You have, for example, you have to commit at least you use the ship for this land for like 10 containers or 20 containers, right? So as to alleviate the uncertainty of your carriers. Carriers will, if you get this commitment, carrier will probably provide better rate for the shipping. Okay, so this is just one of a simplified model, but our model actually built for the engine is more comprehensive, taking into account more other features. And we also built different models for different analysis. Okay, so for the engine, they were using optimization algorithm to solve this model, to optimize it, to select best carriers, and also allocate the container to the carriers in the best way. So you can select the carriers of the selection of the carriers, and the allocation of cargoes will be optimized. The objective is to optimize the total cost and all constraints if they satisfy the demand and satisfy capacity constraint and satisfy minimal quantity commitment. Okay, so eventually the engine will get this information, solve this model, use our algorithm, and to transform the solution to the plan that will be adopted or as a reference for the company to consider in their decision making. Right? So we eventually use our system to help this company to say to handle the procurement for save like millions of dollars, and we also win several awards in the international conference, and also be recognized by the Informs award competition. Okay, although we didn't win the award, we all have been shortlisted in the semifinals. Okay, so this is just a wonderful experience that been through using information technology and business analytics to help company to make decisions in a smarter way, right? To come out with a tool such as like a cheating sheet to help them to make better decisions. Okay? So the analytics have been applied extensively here in this case. We use the data to do the analysis, the forecasting, to do the analysis of the performance of the for the bids of the carriers, and using statistical and quantitative analysis, and also we using like the optimization to drive to analyze the decision making to help the human or managers to automate the decision making and the analysis. Right. So these tools is similar to the cheat sheet that German goalkeeper has, and we provide a tool that they can rely on to make better decisions. And as I say that I have done a number of projects and the research works focusing on business analytics to helping solving problems in logistics, transportation, shipping, and the supply chain management. So one of I just sharing with one of the early projects that have been done for the management of transportation service procurement in global organization. For transportation industry, this is for the shippers, right? As I say, for transportation service industry, in addition to shippers, we also have other two players. One is carriers, okay. One is carriers, and one is the port of facilities, and one is the shippers. And three different carriers. And okay, I see some comments say you cannot see the slide clearly. Can you see the slides?
From my side, yes, yes, Prof. It's quite good.
Okay.
Okay.
Okay. Yeah, I don't know. Okay. Thank you. So yeah, if you have any questions, just let me know. Okay. Yeah. So in addition to the for the shippers, we also have done a few works to help the carriers and also facility operators like port operators. Right. So one of a few works that have been done is for using business analytics to help decision making in terminal management. Right, so in Malaysia, you have a number of terminals, which are quite big in this region. And in Singapore, in Hong Kong, in Shenzhen, also there are a number of terminals. They're also facing some of the issues in how they can make better decisions to enhance their operational efficiency. Right. So today, like 65% shipping delays are caused by terminals. So that's a very, very much incentive that port operators can probably will have to enhance their efficiency. For the part of port in the port, there are different facilities. I think many of you probably also learned in summer students also learned, and many of you are familiar with. They have like when a vessel comes, you will have key crane to move the cargoes from vessel to the port and to the quay, and then the vehicle will move the container to the yard, and there will be a yard crane to manage the space there, and then move later on will be picked by the incoming vessels. And then take out, leave the port. Right? So you can see in this whole process that involve a number of parties, logistic parties, including port operators and internal in terminal vehicles, and also vehicles pick up the products. Right? You have different resources like berth, key cranes, yard spaces, and so on. So how you can and also the cargo volume is very big for the container terminals, and making the company very complicated, right? So let me look at use one example to show what I've been done for port terminals. So what I have been doing research recently, I've been working on a problem called berth allocation, so which is to help port operator to manage their key spaces, right? So this is a key space you can along the sea. There are space to where you can berth the vessels, and the vessels have different sizes, and they can occupy a different number of berths along the quay. And therefore, given the total quay length and the vessels different lengths, and the vessels were leaving for different arrival times, and their containers are different, therefore the handling time also different. So port operators need to decide vessels berthing position. So when and a berthing time. So when you do for a particular vessel, when it will be berthed and where it is going to be berthed, right? So the aim of course, to maximize the port throughput, so that to improve efficiency of the port and the utilization of the berth spaces. And a common objective will be minimize vessels' total waiting time. Okay, so that's the common objective. And when you look at this problem, you see it's very practical problem. Okay, you have vessels, you have quays, you have containers. It's very practical. But if you look at it, it's mathematical. From a mathematical perspective, it is actually very typical combinatorial optimization problem, right? So where you can look at a space and time diagram. So here the timeline showing when different activities will happen, when the vessel will arrive, when the vessel was starting to berth, and when the vessel will going to leave. And along the vertical line is the berthing position. It's the key, right? So berth is just one dimension, but if we expand to the time, it will be a two-dimensional space and time diagram. So in this space and time diagram, what is the vessel berthing activity? It can be represented as a rectangle, right? So which means that a vessel will occupy a space. For example, vessel 1 will occupy this length of the space, okay, continuously along the time for this handling time, okay? So therefore, in this space-time diagram, okay, each vessel's berthing position can be specified as a rectangle. So if you have 3 different vessels, then you can have 3 different rectangles. So the problem is, how are you going to pack these rectangles into this space-time diagram? Okay, so for vessel 1, you can see it pack a space. Okay, for vessel 2, it pack another space. Vessel 3 also pack another space. And the packing decision will tell you what is the berthing time of the vessel. So that will be the left corner along the time space. The left corner will be the of the rectangle will specify the starting time of this berthing activity. Where will be the berthing position for the vessel 1? There will be the vertical coordinate of the left bottom corner of this rectangle. It will show in the starting position of this vessel 1. Okay, similarly for vessel 2 and vessel 3, the packing decision will tell you their berthing position and the berthing time. So now we transform this berthing allocation problem to a packing problem, which is a very typical combinatorial optimization problem. You can see if you have 10 vessels, you have 10 different rectangles. You can put how you're going to put into this time space diagram with the limit on the length of the space position. Okay, you have different combinations, and which will be the best combination. So that depends on your objective. So when your rectangle, their position is determined, their staying time, or they will also be determined. Right, their staying time from their arrival to their departure will be determined. So you can see the cost of your berthing plan will be determined by the position of the rectangles. Right? So that is a variant of the packing problems where the packing cost is determined by the packing positions. Right? So, however, in this case, it very much have a if you look at it in front of combinatorial optimization way, it's become packing problem. So there are a lot of packing algorithms that can be applied. So we developed a new one, which so far is the best one. It can solve these packing problems very efficiently. Okay, it is based on a search algorithm using a very efficient lower bound and a heuristic algorithm, and we can solve instances in up to 24 vessels and consuming like more than half of the running time of the benchmark method, which is the previous best method. Okay, so this is one of the problem that in the port of management. There are a lot of such kind of problems. You can how to allocate resources, but if you look at time space diagram, they become a packing problems. the yard space allocation is also very similar. It also can be transformed to combinatorial optimization problem. Okay, so yeah, so I also do something works for the carriers as well, not only just ocean carriers, but also doing like carriers for the trucking carriers, and also recently doing railway carriers, right? So this is what I've done for the service network design for railway. And in the railway, you have different lanes and different routes, and you have different locomotives, which have the trains. So one key issue is how you're going to determine the timetable for different routes, and how are you going to allocate locomotives for different trains, right? So we do it also in a mathematical way, but in this time we're going to we do it through a more complicated mathematical model, which using a space, time, and a state diagram. Not only we have time, which represent the time of different events that can be staying of the train, running of the train, and so on. Space is which part of the location of the network the train is located. There can be different terminals, and also there can be the train stations. They can also be different the train. They can also the link of the terminals will represent the tracks of track points of the points along the tracks. Okay, and in this case we also have different state to represent the different state of the trains, because the cost and the running time of the trains depends on the state. Sometimes the locomotive is empty. They just reallocate it from one terminal to the other. We call it state zero. Sometimes they were taking passengers or cargoes for the services, right? They can be for route 1 or route 2. So that will be represented by the state. So now the optimization problem is built on a state, time-space state diagram. It is kind of even more complicated than the berth allocation problem. But we also successfully using some mathematical method called Lagrange-based heuristic method to solve the problem, right? So as I see that in addition to what had been done in the logistics management or transportation management, there are also many other problems, important problems that can be tackled by business analytics and optimization and also information technology, right? So you have different activities in the logistics, like or supply chain, right? Start with sales, distribution, production, and procurement, and you can have different type of decision. One is short term in the implementation level, and it can be also tactical term or medium term decisions which last for months. It can be years, right? So, for example, the shipping service network that can be lost for 1 year. For every year, it can be updated. Sometimes it can be more shorter term for seasons. For transportation service procurement, it can in many companies they do it every year, right? Some more like a planning for medium terms. Okay, and for some of the activities are vehicle routing for last mile delivery, so that's a daily term. So like sales analysis, you can historical data to do the analysis. So that's a very typical statistical analysis for sales analysis. And for demand forecasting, you can come out with from historical data in the company, for example, in the ERP system. All right, you can have the sales data, and you can match, do some analysis to see what are the factors will affect the sales data, and help you to provide to come out with better demand forecasting. And so this is demand forecasting. And for production, what we can do is we can using machine learning, machine scheduling. You solve machine scheduling problems for production managers to allocate production tasks for different tasks to different machines. Okay, to coordinate different machines, and so that make it efficient, improve the efficiency of the factory. Okay, so that usually also based on mathematical models and solved by some efficient algorithms, right? So this is also very typical activities in the delivery. That's for transportation delivery. You can assign different routes to different vehicles, right, to cover your demand of the delivery to different stops. So there are also different decision support systems using IT technology, not only to collect the data, do the optimization, but also to visualize the solution, and so allow the users to interact through the interaction to adjust the solution for their better needs. Okay, and so yeah, in shipping they also have container packings, right? So how to pack items to the boxes, how to pack boxes to the carton, and the carton to the containers to utilize the system. So they're also decision support system for container packing, and in behind they also have the optimization analytical engine to solve some optimization problems, right? So there are different business analytics as we see. For the sales data, it's more like a descriptive analysis to show or visualize the reporting the data to understand what is the current situation, right? And based on historical data, you can do diagnostic analytics, which is to use the data to come out with some to observe some patterns in these from these data, so that you can build up some models for predictive analysis. You can do the prediction for the forecasting. Okay, and based on these, if you understand what will be the future situation or future scenario, for different scenario, you can have prescriptive analytics, which is using simulation optimization tools to help decision maker to make a better decision or smarter decision for future situation. So these situations are based on your predictive analysis, based on demand forecast, as we see in the many example. You have to start with some forecasting and do the decision making, do the optimization of decision afterward, right? And so if you're interested in this topic, probably you can also read this book. This is a very classic book about competing analytics, right? So actually, I find a lot of idea from this book in helping company to improve their operations. And essentially, analytics provide a new source of competitive advantage. Rather than competing on the cost, on the price, probably you can compete on how you use the information to make better decisions. Right? So this is also more unique and hard to duplicate it, and you can lasting longer. And there's also a lot of opportunity if you find decision is very complicated, if problems with the operation process, which is complicated, if you use you have data but not using data, but if you have situation where you have uncertainty or risk, so these are good scenario that you can apply these analytics to help you, right? So there are certain guidelines for you to do the analytics. For example, manager can have more analytical thinking, okay, how you use the data, how to optimize the decision. So in a company, when you do work with company, you have to convince them and get support for the management. And it's also very important to, along with the information system, to support the data collection and support to visualize the plan and to support interaction with the users, right? So this is about my sharing today. I would like to share with you my experience of how you applying and developing business analytics tools to help company to improve their operations and decision-making logistics management. And yeah, actually I will keep working on that. And if you have some good problems or idea, I will be very happy, and we can do some collaboration in the future. Okay. So if you have any questions, I will be welcome to address any questions. Thank you.
Okay, thank you very much, Prof. Zhou. Now I open the floor for any questions that you would like to ask with Prof. From the audience. If you have any questions, either you can write in the meeting chat or you just unmute and ask the Prof. Yeah, perhaps we could take one or two questions because we almost come to 11 o'clock. So, is there any question from the floor? No questions. Okay. Maybe, Prof, I could ask you a question. I think one of the issues here, what I could see in the industry is that number one is how to optimize stuffing into a containers, especially from the shipper side, right? We want to know when our product and how many containers we need to use, and either 20 footers or 40 footers. So by this, your formulas, does it will help shippers to able to determine how many containers they need, 20 footers or 40 footers, by matching up the cargoes or the items they're going to send to their partners, to their consignees.
So yeah, I understand that there are different level of decision making, right? So for sometimes in the management perspective, in the planning aspect, you probably you just have to estimate the volume, right? Estimate the volume, and to come out with a rough needs a rough estimation of the containers that you want. But in the operational level, I mentioned one of the application I mentioned. It's called packing, container packing. So this also can be used to determine how many containers you use, right? So you have these different items or different, for example, you already have packed items in the box in the big carton, right? For as I see in local companies, so they have different big cartons. They are interested in how you can pack these cartons in the containers, in this container, for example, in the trucks, in the truck containers, right? So if they can utilize the containers well, they can use we can minimize the number of containers they're going to use. Right? So this is one of the tool that we developed for the firm to minimize the usage of containers. Okay, so they can determine what size of the how many number of containers to use based on the results of this optimization. So this is one application. I think for company they have different there are different applications in terms of looking for how many containers to ship. Right? So this is one application when they have containers cargoes, they want to pack into the containers in a more efficient way, so that to minimize containers, right? So but for like the service procurement issue, the service procurement application. So our application is a container shipping. So they already determine how many different types of containers, what is the quantity they need. Right? It's not for this application. They're not. They already decided, right, how many containers they need to ship. The issue is how to allocate the containers to different carriers. Who are going to help them to ship the containers?
Noted, Prof. Any questions from the audience if you'd like to ask with Prof. Zhou? Okay. It's almost 11 o'clock. I think we come almost to the end. But Prof, before the end, I have one more question to you.
Sure.
Because apologies, it really interests me when I see when in the areas of maritime, especially in port operation, the issues with containerized ship is that when a vessel arrives to the port, right, for container vessel, when she arrived at the port, her stay is mostly 24 hours. Her stays for a container vessel is just 24 hours. And then within these 24 hours, we will do loading and unloadings, right? And as what you said, it is correct. It depends the size of the vessels. Big size can go up to 20,000 TEUs. Small size can go up to 5,000 TEUs. So the issue here is that I do agree. I see your research look into the congestions, especially on the terminal movement. That's when you look at it, does it help? Because every vessel, either from 20,000 TEUs or 5,000 TEUs, their port stay is maximum 24 hours for container vessels. So does it really help for the port to plan how many cranes to be allocated, how many carriers, trailers to be allocated on the ground for this movement, because it needs to be completed within 24 hours, inclusive of the free practice time and all the clearance, right?
Yeah. So normal way they can stay for 24 hours, but in Hong Kong sometimes it's very congested. You have to wait outside sometimes even more than 24 hours to get berthing. So it happens. And also in Hong Kong, there are also not only container terminal, the container ships, but also barges. So barges will carry containers from rivers from China to the container port. And usually if the vessel is the port is very crowded, the barges also have to wait. And for the barges, they usually, in the normal time, they can just stay in the terminal for just 1 hour. But when it's very crowded, they have to stay 8-7 hours, which also make the barges very inefficient. Right? So therefore, we have to do integrated optimization, not only for the services for container terminal, large vessels, but also taking into account how we serve these budgets and also the trucks as well. Okay, and when we so that's some of the motivation for us to study how we can manage the port efficiently to alleviate their traffic issues.
Okay, thank you, but thank you very much for your
Okay.
explanation. I think we come to the end of the session. Before I end the sessions, I would like to have a photo session with everyone. I do request that everyone could
Let me
switch on.
stop the sharing.
Yeah, Prof, you can stop sharing. And I do request that everyone can switch on your camera so that we could have a photo session with Prof. Zhou. And please give your good smile, big smile. All right. I hope everybody not shy to show their face so that we can
Stop
have
sharing, right? I already stopped.
Yes, Prof. It is good already. Already stopped sharing. Now I'm waiting for the participants to switch on their cameras. Okay. Ready? 1, 2, 3. And all right. I think that's it. Thank you, everyone. Thank you for your participation. Thank you for participating in this webinar.
Thank you very much.
Thank you to Prof. Zhou for spending 1 hour with us to share his knowledge.
It's my pleasure.
It's very good to know about your research, Prof. And I hope we could meet again with everyone in our future webinars. Keep in touch. So that's it for today. My name is Dr. Azam from UTAR, and with Prof. Zhou, we would like to thank everyone to participate. Thank you, and have a nice day.
Thank you very much. Thank you. Bye-bye.
Bye-bye.
Thank you, everyone.
Thank you, Prof. It's a very interesting.